There is no question that energy dictates living standards. Therefore, it's also no surprise that people are willing to fight for it. Though standards is another word for baseline in this context, that doesn't mean that societies share the same values in the same way that they share the same living standards. Two societies, for example, may require clean drinking water and a sound healthcare system, but may follow different methodologies to achieve said standard, a recipe for conflict. As horrible as war over resources is, it's understandable. Additionally, leverage is the overarching byproduct of energy due to how much it dictates living standards. This results in a world where those who control energy resources holds an outsized influence, not merely through dominance, but through their ability to sustain the foundations of modern civilization. This is why oil-rich nations have dictated global markets, shaped economies, and even influenced conflicts. But today, the resource that underpins progress isn't just oil, it's semiconductors. And just like energy, control over this vital infrastructure is becoming the defining factor of global stability and competition. But what happens when the most valuable resource isn't a fuel, but a material that powers intelligence itself? Is it replacing oil as such, or will the collaboration between the two industries form a single dynamic that becomes an essential hybrid like resource? Though the Chinese first discovered oil in 600 BC, the birth of the modern oil economy took place with the discoveries and drilling of oil in Pennsylvania of 1859 and Texas of 1901. These events revolutionized the industrial sectors through widely available and affordable oil. This birth of the modern oil economy laid the foundations for the petroleum industry, influencing infrastructure and global markets. It wasn't until the 1973 oil embargo that the West was woken up, so to speak, to the necessity and extent of oil's leverage. Though the event was the first of its kind to change the geopolitical landscape, it definitely wouldn't be the last. The Industrial Revolution started with mechanical style technology and quickly evolved into electronic technology. Though mechanical technology hasn't been entirely replaced, electronic advancements have essentially created a new approach in utilizing oil. However, mechanical and electronic systems still rely on oil and other natural resources as a fundamental energy source. Having worked in the semiconductor industry, I learned its true importance and scale. Microchip technology has paved the way for advancements in military defense, consumer technology, transportation, communication, information, and processing. No one will argue against computers and microchips being the backbone of our world. Computers are everywhere nowadays, and their capabilities are seemingly endless. There aren't many homes or businesses that don't run without them. They've changed the entire world as we know it. Let's not forget that advancements in the semiconductor industry will still have much room to grow, allowing one to think about what else could be coming through the evolution of technology. The mechanical side of modern technology is still evolving and thriving. Engineers are always finding ways to make machinery cheaper, more efficient, practical, etc. It also allows people and businesses to repair their products, something several modern tech companies seemingly dislike. Electronic goods and services, though sometimes lacking in practicality of maintenance, are fast and capable of storing, operating, and outputting software. I will assume we all know what software is. I don't want to get into the nitty gritty of it. Though software creates endless tools for the market, it also creates vulnerabilities. This is all to say that it's no wonder electronic technology has not fully taken over. The key utilities and impact of the two main consequences of oil, machinery and tech, are still seemingly stunted by the strengths of its opposite. I find myself conflicted over the idea that semiconductors could be the new oil, when the industry itself still depends heavily on oil. But then I realized the problem isn't just about tracing what led to what. Suppose we followed that logic to its extreme. In that case, we'd have to acknowledge that semiconductors exist because of meteor strikes and mammalian evolution, making oil just another middleman in a much larger chain. However, while technically true, that kind of reasoning does little to help us anticipate market shifts or economic trends. Instead, a more useful approach is to compare industries and resources based on their tangible impact and degree of control. By focusing on systems and materials with predictable, measurable influence, we better understand where things are headed. This ability to anticipate change allows businesses and governments to adjust their fiscal strategies before the tides turn. Personal conflict resolved. When discussing semiconductors, it's impossible to ignore Taiwan's significant role. Currently, Taiwan holds about 20% of the global semiconductor market, with its government and companies shaping the economy around this industry. As foundry costs and complexities continue to rise, the so called Silicon Island benefits from a significant head start, outpacing private competitors and government backed efforts worldwide. The small island is packed with companies in the semiconductor sector that cover all the ground from chip design to memory, manufacturing, and more. It's important to note that 58% of Taiwan's exports are to China and Hong Kong, making the Chinese the island's largest trading partner. This economic relationship makes up around 15% of Taiwan's GDP. Taiwan has become a dominant force in the industry by specializing in contract manufacturing for semiconductor companies, generating nearly 70% of the global foundry revenue in recent years. Taiwan's push for sovereignty adds another layer of complexity to its already critical role in the semiconductor industry. Beyond microchips, its political status remains a point of conflict, directly clashing with China's long-standing claim over the island. Taiwan's deep economic ties with China, again its largest trading partner, further amplified this tension. The potential consequences of Taiwan's semiconductor industry falling into the wrong hands are grave, and this is a concern that the United States takes seriously. Recognizing the strategic importance of Taiwan's semiconductor position, the U.S. provides military support to help safeguard the island's autonomy. The U.S. and Taiwan maintain a strong, albeit unofficial, relationship built on shared democratic values, economic connections, and security interests. After formally cutting diplomatic ties with Taiwan in 1979, the U.S. passed the Taiwan's Relations Act, TRA, which has since shaped its approach to Taiwan. The TRA ensures U.S. support for Taiwan's self-defense and treats any attempt to alter its status through force as a threat to regional stability. China, no likey. As the oil embargo served as the awakening to how crucial oil was to the world, the chip shortage from 2020 to 2023 served as the same sort of awakening to how vital the microchip resource is. However, unlike the embargo, this awakening was mostly involuntary, assuming the China virus wasn't intentional. The supply chain issues that resulted in chip shortages exposed the world's deep dependency on microchips. Add the lengthy process of turning raw earth materials into microchips, and you get a world that pays a hefty price for progress and leverage. No country can produce a microchip from start to finish. It requires a collective effort from multiple private and government agencies to make it happen. This also means that materials, supplies, and the chips themselves have to travel many miles and cross many borders. The quantity of regulations to make the logistics as cohesive as possible immediately introduces a high level of complexity. The oil and semiconductor industries rely on complex supply chains, but the level of specialization they require differs significantly. Oil production involves a well-defined exploration, extraction, refining, and distribution process. Although technologically advanced, these steps have been standardized and systematized over decades, making the industry more accessible to a broader range of producers. In contrast, semiconductor manufacturing is far more intricate, involving hundreds of highly specialized steps from chip design to fabrication. This process requires cutting-edge equipment such as extreme ultraviolet lithography machines produced exclusively by ASML and depends on a globally interconnected network of suppliers and manufacturers. The extreme precision needed in semiconductor production and its dependence on a few key players make it a far more specialized and fragile industry than oil. This doesn't even include the distribution of profits and incentives to promote collaboration between all parties involved in the production process. The silicon wafers that are eventually cut up into microchips are made of sand refined into silicon. But before a silicon wafer can be produced at a foundry, the chips it contains must be designed. The capabilities, sizes, quantity of errors, and faults means that there are countless ways to design a chip. Once the chips are designed, the most challenging step comes next: manufacturing. Both TSMC and Samsung produce the most advanced chips. For advanced chips to be possible, advanced facilities and expertise are required due to the extreme precision needed for the overall production. The quality control sector follows suit, since even just a 0.01% margin of error can ruin an entire batch, resulting in hundreds of thousands to millions of dollars in lost revenue. This means that the packaging and shipping of these products is a complex and risky step in the chain, even though the complex stuff is already completed. Final chips are sent out to tech companies like Apple, Tesla, and Intel to be used in everything such as smartphones, electric vehicles, and AI supercomputers. There are also indirect factors that influence semiconductor production, such as the geopolitical landscape, which adds layers of complexity. For example, the long-standing tensions between the US and China have created a unique predicament. Despite their rivalry, both nations are deeply interdependent when it comes to semiconductor manufacturing. This leads to what I call the Taiwanese chip crisis, where the US and China find themselves in a tense standoff with Taiwan caught in the middle, kind of like Cuba and the Cuban Missile Crisis. Although there may not be nukes involved, the tensions between the two world powers in this case can be a recipe for war. Both countries recognize Taiwan's crucial role in the industry, not just for its production capacity, but for its cultivated expertise over decades. Taiwan is like a sitting duck, but with a bulletproof vest. Transforming raw earth metals into a finished product like an iPhone involves countless variables, leaving ample room for errors that can lead to major bottlenecks, something the world experienced at its worst from 2020 to 2023. Global power struggles, inherently complex and costly supply chains, the barriers to entry preventing new competitors from emerging, and the relentless push for smaller, more efficient chips all contribute to widespread technological and economic repercussions. If semiconductors are important as oil or more, the real question is who controls them, or the sector that they're in. Though it requires an almost worldwide effort to make chip production and advancement possible, there's always an overarching level of control. Though an argument can be made that the US leads the charge, at best it's still a fragile state because there are just too many variables for things to go right or to feel content with current advancements from the US perspective. Semiconductors are not just technological components, but strategic assets that influence national security, economic stability, and global power dynamics. In other words, semiconductors can be a ridiculously solid form of leverage, and given the necessity of a collaborative effort to make it all possible, that same leverage is distributed to other parties as well based on what they contribute to what the sector outputs. The global semiconductor industry isn't just about innovation and technological progress. It's about leverage. The greater powers of the world recognize that whoever dominates chip production holds significant economic and strategic advantages. As tensions escalate over this critical technology, the battle for semiconductors looks a lot like resource conflicts in the past. This piece is the first in a series about semiconductors being the new oil. I'm extremely excited because this was my first article piece. I've always wanted to make one. I'm not a journalist, nor do I want to be one. These are just mostly opinionated pieces while applying my knowledge and logic to said opinion. I had a lot of fun during the writing of this project, and I can't wait to get started on the next. And I experienced some of the frustrations of like trying to read a script because that's not something that I'm used to, but still had a lot of fun while making this. If you enjoyed this content, please like, share, follow, subscribe, or whatever the social platform that you're viewing this on. Just follow me or message me on there. Or swing me a discussion, swing me a message for a discussion. I'm totally open to talk about stuff. Like I said, this is mostly just opinionated stuff, but I like to apply a legitimate logic to said opinion. So it's not like just like a willy-nilly opinion. And a lot of these things I've always wanted to write down and just put it out there just to like look back on and just see where things go from there. Nonetheless, this was really exciting. I'm really excited to post this first piece. I've always wanted to do this. And yeah, thank you so much for reading, listening, or watching, whatever method you you absorb this by. And yeah, may God bless you all. Thank you.